My name is Dr. Liz Hoffman. I'm one of the scientists here at Ward Science, and today I'm happy to introduce Alex Malinich, who has over 25 years of chemical and biological safety training and expertise. He's been manufacturing and selling chemicals and working with chemicals pretty much his whole life. So we're very happy to have him here.
Again, my name is Alex Malinich, and this is actually my first webinar. Most of the time I'm doing presentations in person. I can look out and see, 90 people in a classroom. This is a little different for me, so it's kind of cool as we can go worldwide. So we want to talk about safety and chemical storage. Why lab and chemical safety? Well, it is also important. One, we want to protect our students, our faculty, our administration against real life risks and liabilities for not practicing lab safety. Next, please. So there's actually, we have to worry about a little bit of duty. We have to worry about a duty of care. So in that classroom setting, and I'll give you an example of a local school district here in the Rochester area. So there was an issue where they didn't actually test any of their eye wash stations. And so the teacher decided that they were going to use open vats of methanol. And so we were going to have those 8-inch wide things of methanol. We've lit them. And the students are actually going to then take a chemical. We're going to look at how they are burning. Unfortunately, one of the students actually caught on fire. So they didn't test any of the eye wash and or showers in their classroom. So when they went to pull the shower to actually help put out the fire, they were off. So there is a duty of care around that in the sense that general laboratory safety has to be undertaken in the classroom. We have to also worry about that breach of duty and how that impacts you as a teacher or the district liability around that. We want to make sure that we actually have a safe environment around us. We actually have safety training. We have compliance to those safety standards and policies and a chemical hygiene plan put in place. You as a teacher have to go through training in the sense that you have an employer relationship with your school. Next. So some of the things that we need to worry about. So we have to worry about OSHA rules and how it affects teachers in the school. You have a right to know in your classroom, or actually as an employee of a school, what are the chemicals that you're exposed to. Here again, every company, we're talking about OSHA, so it's a US rule. Same thing happens in Canada under WMIS, and there are other countries that have the same thing. Let me just stop. There is some feedback going on, so if you can, everybody press *6, make sure we're muted. There's some feedback coming back, so make sure that you're not talking. Thanks, appreciate that. We want to make sure that in that classroom management role that we are managing that classroom, and sometimes that's a little difficult sometimes, but we want to have that, make sure that it happens. Proper safety equipment. So here again, do we have the right equipment in the classroom, whether it's goggles, face shields, and the personal protective equipment, whether it's gloves or an apron. Here again, I'm just wearing a lab coat. There are state rules and regulations that we'll talk about a little bit, and of course local fire codes. So your local fire codes, local fire marshals are a good example. They can trump whatever state law you have. So if a local fire marshal came in and said, I really only want to have X amount of flammables, even though state law might have a different ruling, that's fine, because you kind of have to follow that local rule. We want to make sure that we have a chemical inventory system or even if it's on an Excel spreadsheet or the back of an envelope, we have to have something that keeps track of the chemicals that you have in your operation and or classroom. Here again, that's something that you need to have. There are a lot of really cool things that Ward sells. So they have a chemical inventory management system that's online, so you can access it on the internet. Everything resides on the cloud today. You have to make sure that we have some kind of an emergency employee plan, and we have to understand hazardous waste operations. So we want to make sure that even with hazardous waste, that we're not taking hazardous waste and just throwing it down the drain. We want to make sure that we're getting rid of it in the right way. So if you've ever heard cradle to grave, so basically a cradle to grave operation is whatever chemical that is until it's owned by the school district that gets rid of it forever. So 4,000 years from now, if it came out of the ground, the school district still owns it. A lot of reputable companies today will actually use incineration, if it can be, versus landfill. So it's actually incinerated. So under Section 1, we have a right to know. So OSHA has a right to know hazardous communication plan. That standard actually changed a little bit this year, and we're going to go into some detail around that. HAZCOM started right around the late 70s, early 90s. So, I'm sorry, 80s. So you have a right to know about all the hazardous chemicals that you use in a job and how do you work with them safely in the laboratory. So the first perspective around that, of course, is always going to be the label that you have on the chemical. If you can go next, please. Before I get into actually laboratory, I want to talk about some close encounters that you might have with chemicals every day. So every day, people say, oh, I don't use chemicals. But, if you're cleaning the bathroom, you might be filling your car with gasoline. You might be applying pesticides or insecticides on your lawns, using solvents or acids, drain cleaners. So there's chemicals that can cause injury or illness if they're not handled properly. But at the same time, if handled properly, they can be very, very safe. So we want to make sure that we have common sense versus complacency or inconveniences. Sometimes when you're at home, you can actually run a lab and run a classroom, but yet at home you might, why should I bother to wear safety wear? I might have a little workshop in my basement. I might have a grinder wheel. Should I put a pair of safety glasses on? Well, it's just something and simplistic, and that can be the time when you get injured. So you have to think about it when you're trying to manage a classroom, that you want to actually make sure that you are following those common sense rules, that we're wearing safety glasses, maybe a face shield when we're using acids. We want to make sure that, it's common sense, but yeah, don't smoke, eat, drink, or apply cosmetics, in the lab. Here again, we want to make sure when you're managing that classroom, kids aren't pulling things out and sneaking gum or eating in the lab. We want to make sure that we're never smelling, inhaling, or tasting chemicals. And we want to make sure we keep things off hands, face, clothing, and shoes. And of course, after using any hazardous chemicals, we want to make sure that we wash our hands and face thoroughly with soap and water. Okay, so let's talk about hazardous communication standards. So within that standard, we want to make sure that the chemical manufacturers, so if you're manufacturing chemicals, it's a little harder than just distributing. So if you're manufacturing, we have to make sure what those hazards are. So today, when you have a bottle from Wards, those hazards are going to occur, or they're going to be on the label. We want to make sure that we're getting a safety data sheet. So what used to be a material safety data sheet is now an SDS or safety data sheet. That change took place June 1st, 2015. A lot of the Wards chemicals had safety data sheets as of 2013 or 2014, so way ahead of the change that occurred with OSHA on June 1st. But as an employer, so the employer, meaning a school district if you're a teacher, has to have a hazardous communication program and maintain a current inventory of chemicals and SDSs in the workplace. Yeah, and then you have to go through some kind of a training, which is usually through a hazardous communication training on how to read a safety data sheet and how to read a label. Employees, go back. So employees, we actually have to make sure we have a responsibility too. So, if we're in a lab setting or school, we have to make sure that, we're really reading the label of the SDS. We have to follow instructions and warnings. We have to make sure that we identify those hazards, of course, before starting a job or a lab. So if we're going to start the lab, we want to make sure that we're reading the safety data sheet ahead of time or the label, that we don't spill something and then go back and try to figure out later. And we want to make sure that we're participating in training. Next. Let's talk a little bit about chemical exposure. Here again, so what are the routes of entry? So the things we have to worry about in that classroom setting or a lab, skin-eye contact, inhalation, swallowing, or penetration. Penetration doesn't really occur that much in a lab setting versus an industrial where something is penetrating the skin. We want to talk a little bit about, if exposed. So, inhalation, if you're going to move that person to fresh air. Here again, if you're inhaling. Eyes. We want to make sure that if something gets in your eyes, you're flushing those eyes for 15 minutes. That is an OSHA standard. So we have to have those eye wash stations available so that we can actually go for 15 minutes. I always use the example of my wife. So she was a teacher, also worked in a lab. She actually got picric acid and in her eyes. And one of her friends basically took her head and put it into an eye wash and capped it there. So it helped save her eyesight. But here again, you have to make sure that that eye wash station is available. Those little bottles that you might see that are about this big, that is not enough water to actually have 15 minutes of washing. It's not the most comfortable thing to stick your head into water, but it's you have to do it. Skin, if you get chemicals on your skin, we want to make sure that we're washing with soap and water, and of course, swallowing, we're going to seek immediate medical condition. On the right-hand side, you're looking at the different symptoms of possible overexposure. Next. So, chemical hygiene plan. So, the thing with the chemical hygiene plan, we want to make sure that we have one for every school. So here again, this is an OSHA standard that we have. We want to make sure we're describing procedures and handling of hazardous chemicals. So we want to make sure that we have that chemical hygiene plan. So we have a standard operating procedure, how we're going to work in that classroom. So we want to have criteria for implementing those controls and routine testing of those fume hoods. So we want to make sure that, here again with a fume hood, we come in the fall and we want to make sure that the fume hood is actually working, and we want to make sure it's certified. What is that exposure for the fume hood, so that over the summer a bird didn't actually end up in the vent. So we want to have that certified at least once a year, make sure it's working. We want to make sure that any kind of laboratory operation we're doing require the approval of your employer. So if you just try a rogue lab, we want to make sure that it's safe. We also want to have a chemical hygiene officer in every school or lab. So we want to make sure somebody's responsible for safety for others. And of course, we want to make sure there's any additional protection when working with carcinogens, mutagens, teratogens. Here again, those aren't usually used in schools, but we want to make sure if that is happening more at a college level, that there is some additional requirements around those. Is this your storage system? So if you want to look, if you want to go back, so these are actual pictures that were taken off the internet. I've been using these for a couple of years, some of my safety training. This is an actual lab in a school. So this is kind of how they store their chemicals. It's not the greatest way to do that. There is no segregation. Here again, I want to talk a little bit about segregation. We're going to get into details. So when you buy chemical boards, we have color-coded systems. So red is flammable, yellow is an oxidizer, and there's a little cap here that's yellow. So you can see green is our general storage, blues are the poisons. We want to make sure they're on the lock and key, and white is corrosive. You can see the one in your on the PowerPoint is just a random mix of A to Z. It's not a great storage system. Next. So we're going to go over chemical labeling. So that's our first line of defense in our chemical labeling. Next. So when we get, and here again, we're living in an SDS world today. So we want to make sure, and I talked a little bit about our storage codes. Those are actually on the top. So it's not only does it say storage code green in a band, but we have a color cap now today. So this is a storage code green, or a low hazard chemical, sometimes referred to as general storage. We want to make sure that people understand our storage system. By using this storage system, there's 5 different ways to store it. So we have corrosives, flammables, oxidizers, toxics, or poison, and general storage. Very simple. It's going to eliminate any kind of worry in that classroom setting as you segregate it by color code. There are others, storage systems that are on the market today. Some of them are very confusing. They can go up to 18 different ways to store your chemicals. Some of those, this is a very simple way, and a lot of industrial companies use this, especially in academia and college and beyond. Next, please. So chemical labeling. So what do we have to worry about? And that's changed a lot since June 1st. So we have a very robust label today for our board's chemicals, but today it actually has to have an identity of that chemical. We have to have a name and address of a manufacturer, who made the chemical. There has to be a signal word. So those signal words might be warning or danger. There are hazardous or H&P phrases. There's special handling instructions. There's some basic PPE, which are what do you need to do to so personal protective equipment. So first aid, response, and cleanup. So today, you can buy a chemical in a concentrate format. And if you're making those chemicals for your classroom, we want to make sure that they're labeled properly. So if you're using them within that class day, that 8-hour period, and not storing them overnight, it's a little different than if you're making bulk and storing them overnight. So if once they're stored overnight, we have to follow GHS rules, and we'd have to create your own labels. If you buy a chemical from Ward's and it's already pre-mixed, you can just put that back up on the shelf. So we also have to worry about unlabeled containers. So anything that you see as unlabeled, so you find it in the back of a classroom, we really want to consider that dangerous. We don't know what's in there until we can figure out what it is. If you're transferring chemicals from one bottle to another bottle, that bottle that you've transferred to has to be labeled. So on your PowerPoint, you're actually going to see on the left-hand side, you're going to see the new icons. So these are actually pictograms. The pictograms are designed to have a red diamond around them. So when you see a pictogram, and you may actually have a chemical that has no pictogram, so it may not be classified under GHS. So don't worry if you don't have some new chemical. So potato starch, here again, a general storage, and it says this substance is a mixture not classified under GHS. It's not going to have a pictogram. Next to it, of course, acetone, it's going to have 2 pictograms. So we have a flammable and exclamation point. So the different there's different pictograms around those warnings, but when you see the red diamond, that's actually going to give you heads up ahead of time that you might want to read that label. Here again, we should always read it, but the idea around the GHS, or the Globally Harmonized System, is it's actually going to create a safer workplace or laboratory for you. So the 9 that you have to worry about, we have, and I call it the little running man with it's got a lung there, per se, the health hazard. And that can really be anything in the sense of a teratogen. Can you go back? So it can be a teratogen. At the same time, flour also has that same health hazard. So in an industrial setting, flour in a mill is a dust hazard. So it also has an inhalation dust hazard. There's a flammable symbol, an exclamation point. There's a gas cylinder as a corrosion diamond. There is an exploding bomb. There is a flame over a circle. Now this is the one, it's an oxidizer, and this is the one that gets most confused with the flame. The difference is the oxidizer has a little circle with a flame on top, so that for oxidizer, and the flame, if you look, is a straight line with a flame above it. Then there's a aquatic toxicity, and then a skull and crossbones. Next. So here again, you may have product that's in your lab or your school that may have been manufactured previous to January 1st, 2015. Those labels still can be in existence. The changeover again occurs in June 2016, where all of the labels have to be in your lab have to be converted to the new GHS format. Let's go over some of the GHS label requirements. So we have a signal word. So that signal word is that danger, warning. You'll see that a lot of chemicals today are the same chemical you might have used yesterday might have a different warning or signal on it, word that it was yesterday. So you might have seen caution. If you bought something last year, it might be warning or danger this year. Here again, chemicals have been classified under GHS. And so you might be a more severe hazard than you're used to seeing. Here again, that's supposed to make you step back and read the label. Nothing's really changed in the chemical composition. It's just how it's been classified. Next, please. So the other GHS requirements, we have hazard statements. So these are phrases that are assigned to the hazard class or category, and then we have hazard statement codes. So it can get very wordy or robust on these labels. So here again, this is acetone, and it's hard to see on the label, but it's filled with a lot of words. So danger, highly flammable liquid, causes serious eye irritation. And there's a lot of words that are going to go through what happens if you get it on the skin, what happens if you get it in your eyes. What are the things that we have to worry about before we use the chemical? So here again, more robust labels that you're going to find today than you have in the past. Next, please. Precautionary statements. So these are phrases, or they're sometimes called P phrases, and those are phrases or pictogram, the phrase and or the pictogram that describes the recommended measures that really are used to minimize the adverse effects around using the product. So a GHS label is going to have those precautionary information ahead of time. Here again, if you are making your own chemicals for your lab and storing them overnight, you'll have to do the same thing. You'll have to classify and also label your own chemicals. In the past, you might have been able to just put it on the shelf, one NaHCl, one normal hydrochloric acid. Those now have to have all the P and H phrases ahead of time if you're going to make your own products. Not a lot of teachers have the time to come in at 5 o'clock in the morning anymore. Like some of my old teachers, they used to make all their stuff ahead of time. It's a little harder to do that today with all the different testings and things that are going on in the classroom. Next, please. So some other GHS label requirements we want to talk about. So product identifiers. We have to worry about what the product is. So there's identifier, yeah, this is acetone, and we actually have to have a UN number around that. And then we want to make sure that the chemical identity is there, and there might be some mixtures or alloys that might be on a mixture that we have to identify. So there are other hazards that might be there in those mixtures. Those are usually going to occur, you'll see it on the label, but also under the contents, but under the STS too. Next, please. Supplier information. Here again, in the past it wasn't a requirement, it is today. So name, address, telephone number, and manufacturer supplier has to be on the label. If you're making your own chemicals under GHS, you actually become a chemical manufacturer, and you would have to put your name or your school's names as that person making the chemicals. Next, please. So here's a pretty robust label. This is only calcium carbonate, but you can see there are a lot of H&P phrases here. There is a warning, and there is a pictogram around that. So even though you would think calcium carbonate is pretty innate, there could have quartz in it, and so that's why it has a warning. Here again, you can see Ward Science, the chemical abstract number, the catalog number, the amount, and the formula weight around there. In the lower right-hand side, you'll see a lot number. So if you want the cheating way to learn how to read these lot numbers, so you can see an AD, and I think it says 13000. So the Ward uses a Julian date. So the first digit is 2013, and there would be a 3-digit code after that. So if it was 13001, it'd be January 1st, 2013 is when it was manufactured. So you can see the manufacture date of the product when the Ward manufactures it. Next, please. Safety data sheet. So here's a secondary section around. First part is our labels. The second part is safety data sheets. Next. So there's 16 different parts of the safety data sheet. Next. So we want to worry about. So the safety data sheet. This is a new format. So all of these safety data sheets. So we have. You're going to get. There's e-files today that occur on the Ward's website. In fact, you'll see both for Canada, French, and then English for the U.S. So you've seen a 4-page sheet. Here in the U.S., it would be a 2-page sheet. You have to have those SDSs that have to be available. So you can have those on an internet site or some kind of a network at your school. You may just want to print it out and have it as a paper file. So there's 2 different ways you do it. You just want to make sure that they're immediately available. They are in a section or part of your school where you can get to them. If you use the Ward's Chemical Inventory Management System, those are all on a cloud, and you could actually access those anywhere with your chemical inventory. Next. So let's look at some of the first part. So you're seeing the first part of that the SDS. So you can see on the left-hand side, you're going to see calcium carbonate. You're going to see the pictogram, the warning symbols, and some information around that. Next, we're going to go through all these 16 parts of the SDS. So in section 1, you have the identifier of who that manufacturer was. In section 2, you're going to have all the health information around the chemical. So you want to look at number 1 and number 2 first. So number 2 is probably the most important, with number 1 being the name of the chemical. Number 2 is what are the things I need to worry about. Next. So in section 3, we have a chemical composition. So you're not going to see a lot of trade secrets like you might have had in the past. People used to try to hide formulations. There are trade secrets that are allowed under GHS, but really have to spell out some of the compositions of the chemicals and the ingredients around those. And you'll see the composition percentages. Below that, you're going to see some first aid measures. So here again, an important part of first aid. You want to read that ahead of time. What happens if somebody comes in contact with a chemical? Next, please. Section 5 is our firefighting procedures. Here again, as teachers, as lab administrators, we aren't firefighters. So there is some common information there, but a firefighter is going to want. You may be trained. And if here again, if you are using if you are trained to use a fire extinguisher, you have to make sure that you're trained on an annual basis. You can't just say, hey, I can use a fire extinguisher. That is training that your employer has to provide to you. Section 6 is accidental release measures. So what happens if I spill it? Here again, it's nice to read that ahead of time, that we can actually read the SDS. Next. Section 9, here, physical and chemical properties. Great thing you can do. So if you want to run a cool experiment with your students, they can Google a lot of things around the composition or the physical characteristics of a chemical. At the same time, they can actually use the SDS to look at, what is the melting point, what's the freezing point. So you can get a lot out of that section 9. And then section 10 is going to be the solubility of the chemical. Next. Section 11 is toxicological data. So the more hazardous the chemical, the more toxicological data that's going to be there. Now that's kind of where you start beyond that in section 12. OSHA doesn't care anymore, but other people do. So the EPA worries about section 12, or ecological data of the chemical. What happens if it's released into the environment? Next. Section 13 is our disposal considerations, and of course 14 is transport. So remember, if we're taking a chemical that's hazardous, putting it in our car and going to another school, we want to make sure that, one, you have to be trained or certified to do that. You can't just put it on the road and go down the road with a chemical. So there is transport information around shipping a hazardous material versus a non-regulated product the DOT doesn't worry about. Next. Section 15 is just other regulatory information. It might be around some local or federal laws around CERCLA or RCRA. There's RCRA codes around, so if you're getting ready hazardous waste, sometimes Safety Clean or different companies might ask, what is the RCRA code of the chemical you're trying to get rid of? And then there's some additional information under 16. So all those safety data sheets have to have 16 parts as part of the new guidance. In the past, it was as low as 8 or 9. And now they have to have 16 parts to be compliant. So all SDSs have to have 16 parts. Next. So classroom and laboratory specifications. So next. So we don't worry about our classroom. So there are some guidelines around the right classroom. You want to make sure if you're reading or you're planning for the future. Here again, it's lifelong learning. Sometimes we might be put into a classroom that might have been the music room. It might have changed. So as you get an opportunity in the future to build a new classroom, or there might be budget dollars available, we want to make sure that people are reading the ICC International Code or building codes around that. There are some NFPA guidelines or Uniform Fire Code that set some room capacities, and there are your local fire marshals can be great help. NSTA also publishes a guide on planning schools and science or facilities in their second edition, and they actually have some guidelines around what they feel is ideal square footage for a classroom. Here again, here's an ideal classroom. So if you had a chemistry classroom, we want to make sure, do we have a fume hood? Do we have an acid cabinet? Do we have a flammable cabinet? A poison cabinet? There is open chemicals shelving with a lip. If you're in the state of California, has to be a closed situation. Here again, deionized distiller for our lab. These are, some of these are just ideal things you want to have. Gas cylinders. If you have gas cylinders in the classroom, we want to make sure that they're restrained to the wall. We want to make sure we have the right waste receptacles. Telephone numbers with emergency numbers are posted. It's really tough when you get into a situation and in an emergency and trying to look for a number. Ideally, you would have 2 doors. Not a lot of classrooms have that, or even lab settings. But you want to also have that chemical inventory. So it's posted outside or posted on might be in the main part of the school, someplace where you can get it other than maybe in that chemical storage room or in a someplace where something happens. Smoke detector, GFI, of course. Even a biology classroom, if you are dissecting specimens, it's ideal to have GFI plus gas supplies. We want to make sure that we have a safety storage, a shower for all of our classrooms. Eye wash set for 15 minutes, fire extinguisher. But here again, we have to be trained if we're going to use the fire extinguisher. And of course, a chemical spill kit. So, all classes should have a nice little chemical spill kit. They don't have to be very big. They can sit in, but we want to have these ahead of time, so if something happens, we can actually deal with that chemical spill as it happens. Next, please. So ventilation. So we want to make sure that our room is ventilated. So we want to make sure we have at least minimum 6 air changes per hour. With venting, we want to vent outside. So we don't want to have that circulation that goes on inside. Fume hood and chemical vault ventilation should be separate than room ventilation. And of course, with the fume hood, we want to follow the ANSI Z 9.5 specifications. So we want at least what's called 80 feet per minute of velocity. 100, of course, is preferred. We don't want to locate that near a door, and we don't want to store chemicals in our fume hood. So we want to actually have a separate storage area. It's hard to work in a hood and actually have chemicals in them. Here again, some other teacher might have chemicals stored in there. If you're trying to do a reaction, they might react what's in there. We want to make sure that we're measuring our face velocity every year. So even though the door goes up or the window goes up and down, we want to make sure that we're measuring the face velocity. We know that it's working. There isn't a bird nest, say, in the venting. It's truly, truly working. And the sash really shouldn't be raised above the most efficient point. So a lot of times you want to take a little piece of tape or mark off where that most efficient point is. Next, please. Fume hoods can be confusing. Here again, a lot of reps out there can help you with that. There's a simple thing at the bottom. usvwr.com or bwr.com can help you. There's a full line of how to look for fume hoods in the future when you're trying to purchase one. But here again, we want to at least have 100 feet per minute. Next. Eye wash. So we want to make sure we have an eye wash within 10 seconds of a walk, about 25 feet in the classroom. We also want to make sure that we're not going out a door and down the hallway to find those. So they really should be in the room. We want to be able to, they need to flush both eyes. They also they have to flow for 15 minutes, and they may need to be hands-on. So if you turn them on, you can't just keep the handle on. They have to just, when you turn it on, it stays on for 15 minutes. Eye wash bottles don't meet the lab standard. I talked about a little bit about that, and we want to make sure that we're testing those eye washes once a week. One of the reasons around testing those eye washes is that we want to make sure that they don't just sit all year. They build up bacteria with stagnant water. As soon as you turn that eye wash on, the one thing you don't want is you have chemicals in your eyes, and you don't want lots of other things in your eyes too. There's a lot of options around eye wash, so they can be deck mount, gravity fed, faucet mount. Here again, there's opportunities if you don't have a plumbed area. There are gravity fed that can fit into your lab very simplistically. Safety showers. So there's an ANSI standard around that. So they all should have a Z 358.1 standard on that. They really should be, ideally within 10 seconds of where you're working, the same room as work. And they really need to be tested on a weekly basis. Here again, I say weekly. Can you test at least monthly? Testing is a good thing. Do they work? Take a pail, put it up there, pull the bottom, or pull that handle, and then the handle should stay on. So you shouldn't just pull it and keep it down. It should stay on until you push it back up. So goggles. So here again, I'm wearing glasses right now, but you can get goggles to go over top of glasses, or they have to have that Z87.1 standard, which you'll find on the side of goggles. And you can get indirect and anti-fog coatings today. So you want to make something that's comfortable where the students, the worst thing that can happen is you have a student that's wearing them and they're getting all fogged up, and they stick them on the top of their head, and they're really just because they can't see through them, and it's not doing them any help. There are impact goggles and glasses, but they don't provide chemical splash protection, so you can find those sometimes in a technology environment or industrial arts, as we used to call it. Those would not work in a chemistry classroom. Next, please. Acid and flammable cabinets. So here again, we want to make sure that we have an acid cabinet and a flammable cabinet. We want to be able to organize those chemicals in storage cabinets and make sure that they're safe and effective. Next. Here again, there's different aspects here that you can see: acceptable, better, and best. So there's different things that you can look at in the way that you're storing chemicals. Open shelving with color coding is perfect. Of course, a separate flammable cabinet is more ideal. If you don't have money for a separate flammable cabinet, we want to make sure that we're separating our oxidizers and our flammables by at least 20 feet. So we can't really keep those together. Here again, if you're putting your flammables in its separate cabinet, that's a more ideal setting. And of course, if you had separate acid and corrosive cabinets, sometimes those are really nice if they're underneath your lab fume hood, so that you're minimizing the amount of walking that you're doing. Next, please. Chemical Inventory Management System, or SIMS as it's called. So Wards has a chemical system. So here again, let's talk about the storage system. We talked a little bit at the beginning. We don't want to store our chemicals A through Z all mixed together. If you look, acetic acid, acetaldehyde, both are A, but also mixed together, if they leak, would create a very good exothermic reaction. We want to store our chemicals so they minimize, interactions, in the labs. Liquids really should be stored on those lower shelves. We want to make sure that something's not above your head, so that you grab it at, and the cap's not on, something comes on you. We also want to make sure that we're segregating certain items, like nitric acid should have its own cabinet. And of course, sodium metal, as a dangerous and wet, is stored. They come in these nice little safety packs today, but those are very nice to segregate those separately. And you're storing them, they come in mineral oil, but you want to keep them in that mineral oil. With a safe and simple storage system that Wards has, we have closed door shelving. Of course, it's mandatory for California. We're going to have some kind of an anti-roll lip in the front, and we want to make sure that it's anchored to the wall. So what we're saying can happen is a shelving unit comes down on you if it's just a simple shelf that's stored, if we put too much weight on it. Shelves really shouldn't be too deep. 12 to 14 inches is ideal setting for that classroom or that lab. And ideally, if you can have polyethylene trays for secondary containment for liquids, is really nice. The worst thing that can happen is you come in on a Monday morning and you come to the spill that you have to clean up. Talk a little bit about large bottles, if they're down below versus above your head. And really, acids need to be stored in that segregated cabinet. One of the things you want to do is there's a spot. I want to make sure that you take a China marker or some kind of a marker, mark down when you receive that chemical. Here again, it may be your classroom, but next year you may get promoted and move to a different school or go on to do something else, and somebody may adopt your classroom. So things that were in your head, someone can see, I only got those last June, or, I got them in June 2004. So, I was in a school district in another state, and I told the teacher, if the chemical's older than you, it's probably time to get rid of it. So there were things that were in her classroom that were from the 70s. And so it was, that helps sometimes maintain your inventory. And a lot of times there may be chemicals that aren't used in your curriculum anymore, and you can evaluate those at the end of the year. But make sure you're storing your chemicals by your color codes. This is, you can see a color-coded area. So there's, green, red, yellow, white, and blue. It's here again with the color caps. It just makes it so simple to look around the classroom or the lab or your chemical storage area and see the different colors on the top. And if something is, together like this, of course, yellow and red, we want to segregate that by 20 feet. But you can see that just by the color codes at the top of the bottom. Next. With the chemical inventory management, it's completely cloud-based. It's going to be able to store. It has over 2,300 chemicals in the database, but you can also add your own chemicals. So $49.99, for a building, you can keep track of all the chemicals in that building, and you can sort by, what are all the hydrochlorics in our building? You may have run out of something, and another teacher down the hall might have it in one of their, in a biology classroom, or maybe a physics setting that you didn't know, and you can actually share instead of trying to rush an order or get something flown in overnight. It's so expensive to try to ship chemicals. via airplane, whereas you can actually manage your chemical inventory a little easier. Spill response and PPE. So we talked a little bit about spill response. You know, I had my my kit here, so we want to make sure that in the setting that we know what we're doing. We want to be kind of trained to do that. It's really good if you can get together as a department, kind of go over the setting. What happens? What are the most hazardous chemicals we have in our lab or our classroom? But if something happens, you know, worst case, let's evacuate the area. Let's notify a supervisor, a chair. In some case, you know, the principal. We want to make sure that there's an emergency response team that's needed. We do need to remove any ignition sources if there's flammable, and stay away until it's notified for safe return. You know, if it's a simple little, something like Bioret or Benedict solution in a biology classroom, it's small enough that you can handle it yourself, then that's great. But if you don't feel comfortable doing it, we want to make sure that you get out of the area and that you have a trained professional help you. There are a lot of spill response kits that are available. We want to make sure that we also have acid and base neutralizers. So if you do spill an acid or base, that we can neutralize those right away. And of course, flammable absorbents are very simple. We want to make sure that we're wearing our nitro gloves, goggles, and we have wipes available. We want to be ready for a spill. So I talked a little bit about, take your department, have a meeting about it, go over, rehearse a spill. What happens, so you can find a lot of problems. Maybe you decide that, if something happens, we're just going to hire somebody. There are companies out there that can take care of that for you. We want to make sure that we have an up-to-date inventory. Here again, at the end of that class year, you can use that inventory to plan for next year. What is next year's curriculum? How's it changing? We're changing our textbooks. We don't need this anymore. Hey, we're going to need this. Or there are ways to share chemicals within your school. We want to make sure that we're getting rid of old materials and chemicals, that we're actually and completing that inventory yearly. Next. So spill response and personal protection, with those spill kits. There is assistance. If you do need help, you can also email sciencehelp@bwr.com. And there is a full line of products. So, there are simple things like, disposable aprons. We want to make sure nitro gloves are perfect. And one of the things I like to talk about sometimes are nitro gloves. Of course, I have big hands and I'm putting on small gloves. But, when you're dealing with a glove, we want to make sure that we grab that bottom of the glove. And, we're turning it inside out. So actually, if something's on your glove, it's on the inside. Next. So this is kind of like that proper removal. It's kind of like I just did it simplistically, but it's kind of written out for you. Next. Safety first. Here again in that classroom, that lab, wherever you end up in life, you want to make sure that truly it's the safe way is the best way. We don't want to cheat the system. We want to make sure that from a due diligence perspective and a liability perspective, we're doing it the safest way. I want to thank you so much for joining. I know I talk really fast, so it's about 45 minutes into the presentation. If you have any questions, you can go them online or was *6 to unmute?
Yes. So there is a question that actually came in, Alex. Is there an inventory option available for more than one building, like let's say multiple schools?
Yep. Yeah. So there's another, besides the $49 version, there's a $199 version that goes up to 20 schools. So it's about $10 a school, or $10 a building. So that would for a district of 20 buildings for $199. Any other questions at all? I hope you have a wonderful evening and be safe.